What if the secrets of the cosmos were hiding in plain sight, waiting for someone with the right mind to uncover them? Isaac Newton wasn't just a scientist. He was a seeker, driven by a relentless curiosity. From a single falling apple, he unveiled the invisible laws governing motion, gravity, and even the stars above. But how did one man decode the language of the universe? Step into the mind of Newton and discover the radical ideas that still shape our world today. Isaac Newton was more than just a scientist. He was a true visionary. In the late 17th century, Newton unlocked secrets of the natural world that scientists had puzzled over for centuries. His work spans physics, mathematics, astronomy, and even optics. And while many of us know him for the Apple story, his impact reaches far beyond that single moment. The famous Apple story and the birth of gravity. Let's start with the story of the apple. A tale that might sound too simple to be true, but has roots in real events. Imagine Newton sitting in his garden, watching an apple fall to the ground. Most of us would see this as ordinary. But Newton, he saw it as a clue to one of the universe's greatest mysteries, gravity. This moment sparked Newton's question: why do objects fall down instead of sideways or upwards? This led him to formulate the law of universal gravitation, which states that every object in the universe attracts every other object with a force proportional to their masses and inversely proportional to the square of the distance between them. Newton's laws of motion, the foundation of physics building. On his ideas of gravity, Newton formulated his 3 laws of motion, which became the foundation of classical physics. Let's break them down. First law of motion, the law of inertia. Newton's first law states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force. Example: imagine a hockey puck sliding on ice. It won't stop until something else, like a stick or a player, interferes. Second law of motion, F equals ma, force equals mass times acceleration. Newton's second law reveals the relationship between force, mass, and acceleration. This law tells us that the harder you push an object, the faster it will accelerate. Example: think of pushing a shopping cart. The more force you use, the faster it moves. Third law of motion. Every action has an equal and opposite reaction. Finally, Newton's third law explains that for every action, there is an equal and opposite reaction. Example: when you jump off a boat, the boat pushes back, creating a reaction that sends it drifting in the opposite direction. Universal gravitation, Newton's big idea. With these laws of motion, Newton went even further and unlocked a universal truth about the cosmos. His law of universal gravitation explained how every object, from an apple to the moon, is drawn to every other object by an invisible force, gravity. This idea transformed how we view the universe. Newton's discovery meant that the same force pulling the apple to the ground was responsible for keeping planets in orbit around the sun. The invention of calculus, a mathematical breakthrough. But gravity wasn't the only breakthrough. To solve the complex problems in physics, Newton needed a new kind of math. So he invented one: calculus. Explanation: calculus allowed Newton to describe changes over time, whether it was the motion of planets or the curve of a river. Fun fact: Newton wasn't alone in inventing calculus. The German mathematician Gottfried Wilhelm Leibniz independently developed it around the same time, sparking a famous rivalry. The reflecting telescope, seeing beyond the stars. Newton didn't stop at theories. In 1668, he designed and built the first reflecting telescope, improving our ability to observe the stars and planets. His telescope used mirrors instead of lenses, reducing distortions and providing clearer images of celestial bodies, an innovation still used in modern telescopes today. Newton's legacy, a lasting impact on science. Newton's contributions to science are still the backbone of physics and engineering. His theories guided scientists for centuries until Albert Einstein came along, building on Newton's work to further understand the mysteries of the universe. Newton's curiosity about a simple apple led to insights that changed everything, from the way we build machines to how we explore space. Isaac Newton's curiosity, ingenuity, and relentless pursuit of knowledge reshaped science forever. His work proves that sometimes the biggest discoveries begin with a simple question. Who knows what other secrets the universe holds? Waiting for someone to ask the right question? If you enjoyed learning about Newton's groundbreaking discoveries, check out my video on Nikola Tesla, another genius whose vision continues to power our world today.